The demo that we're going to present will discuss flights data, and we'll try to address a simple but not that simple business question or business decision, basically to predict delays of flights, and also understand the, let's say, the root cause, what impacts, whether it's the different airlines, whether it's the different days, whether on a weekend or on a Christmas Eve, or how the weather, like rain or snowing, impacts the delay, and then try to run a classification algorithm to predict whether a flight is going to delay more than 15 minutes or not. Now, the overview architecture of the demo is basically we're simulating or loading historical data from 2017 to train the model. We're then running the model and validate it on flight data from 2018, and then using Kafka, we're simulating live stream of flight data from 2019 to run a Spark streaming job, build a feature vector, feed it to the classification model. In this demo, we'll show a random forest tree, and then visualize everything using a Zeppelin notebook. So let's move on to the live demo. Okay, so as soon as you have your GigaSpaces account up and running within 2 minutes, and you get a few of predefined or sample application. One of them is the flight delay application that we're seeing here. First step is, of course, as we mentioned, loading the data. So in this specific case, we are loading the data using Spark from a CSV file. Of course, as Sharon showed earlier, it's also very easy to load it from a SQL database, whether it's a NoSQL database like Mongo or Cassandra, whether it's a data lake and others. Once you load the data, you can see the data schema, and then you can start interact with the data. So this is a simple example how you can run a query and look at the timestamp and the different the airlines, the origin and destination. So the first line shows you a United flight from Denver to Honolulu on March 8, 2017, and so on. So I have my data loaded to a Spark data frame. Then with the Zeppelin notebook, I can easily visualize the data, whether it's, we picked here 4 different airports, San Francisco, Orlando, Dallas, and Denver, and you can see here number of total flights versus delayed flights for each airport, and of course also have a look at the airport popularity. So for example, the Orlando airport has 69% out of the total flight count of all of the flights that are accounted to those 4 airports specifically. Now, the next step, of course, where we want to write the data from the data frame to the space in memory as part of the InsightEdge. So you can easily save the data frame as is to grid. So it's a very similar API to Spark with the added value of saving it to the in-memory multimodal store. Now, once it's in the in-memory multimodal store, first of all, you can easily leverage our advanced indexing. We have different indexes for text search, for geospatial, for collections and others. And you can also leverage our in-memory resiliency, so you can recover from failures. You can, if a Spark job or a Spark executor fails due to an out-of-memory exception, we store the Spark executor state and continue from the same point it stopped. So the entire solution is it benefits the high availability and resiliency on one hand, and also the speed and scale, as opposed to loading data from a data lake to Spark in memory, which is very slow and requires a lot of bandwidth and network in data movement in the process. Now, once you query the data, you can easily see here, if you would describe the execution plan or the metadata, the fact that you are querying data that was originated from San Francisco, for example, immediately using our sharding or partitioning schema and the indexing. So we are pushing the predicate, the actual filtering, to the server side, which means that instead of scanning all of the data, we'll scan only flights that were originated from San Francisco, and then it usually benefits from a 10 to 30 times faster response time by the fact that you can skip most of the scan. And again, you can easily use the InsightEdge JDBC interpreter to run any types of SQL query that you want. For example, in this case, we are aggregating let's say the on-time ratio, how many flights in average or ratio were took off on time based on the flight number. So we can see here flight number, which has 97 something accuracy. Now, the next step is, of course, we want to enrich the data, the flight data, with external sources. In this specific example, we've chosen to enrich it with weather information. What we're doing here is basically we're enriching based on the timestamp of each flight and the geographic location of each airport, each record with the weather information, the wind speed, whether it was raining or snowing, the minimum and maximum temperature in Fahrenheit of each flight. And we're using one of the GigaSpaces InsightEdge feature, which we call the distributed task. You define a task execution function, and which is run. You can execute and run in a distributed manner, which means that the enrichment logic runs in parallel on each partition on the server side, and then when you execute asynchronously the actual distributed task, the entire data within the space is enriched in very fast and very easy to generate. And here you can see just an example of a flight from San Francisco to Florida. You can see the wind speed, you can see it wasn't snowing, you can see the temperature, like minimum and maximum, 72 to 111 Fahrenheit degrees, and so on. Now, once we've loaded the data, we've visualized the data, and we enrich the data with the weather information, we're now left to prepare the feature vector and validate, train the model and validate it. So as we explained earlier, we're splitting the data to a 50-50 split. 2017 data is used to train the model, and then 2018 to validate the model. Now, in order to train the model, we've chosen in this case a random forest classification algorithm. Basically, it provides you a yes or no, whether the flight will be delayed or not. Then you define the different metrics, like true positive, true negative, and so on, whether a flight that was predicted to be delayed was actually delayed or not, and so on. And we're able to train the model and measure its accuracy. So here we're doing the actual validation with the prediction, and then you can see in this case the 2018 validation was got a score of 79% accuracy. Now, next step is, of course, is saving the model to the space. So the model is stored on each partition in memory, which provides you the speed. And then we are generating or creating the Spark streaming context, which basically gets each event from the Kafka, builds the feature vector, and gets the score from the model. So here you can see the actual mapping, where each, based on the prediction score, we're adding a new column, which is called either delayed or okay. And if we look at this now at the space, if we scroll to your right, you can see the new column on each flight, whether it's expected to be delayed or not by more than 15 minutes. And then, of course, you can also query the data and visualizing it, so you can easily see the ratio between delayed and non-delayed 56% to 44%. So again, end-to-end flow from loading data from CSV, or it could be any relational, non-relational database, visualizing the data, querying the data, enriching it until you train the model and run it with a Spark streaming job on your Kafka on events coming from Kafka. So very easy to start with. All those data sets and applications are bundled with the GigaSpaces account, which provides a very easy way to play and learn how to work with the system.